Math 1202 Pythagorean Theorem. This unit's all about triangles. It's all about finding the sides of each triangle using a particular formula and then squaring each side. So to understand Pythagorean Theorem, you have to look at the triangles and realize what type of triangle are you allowed to use Pythagorean Theorem. And we'll go into what that is there now in a moment. And the rule is, if it's got a square corner right here, like this, in other words, if it's a right triangle, you can use Pythagorean theorem to figure out any side you wish that you want to find out. So it can be used on this one. It can be used on this one here because it's got a perfect corner. It can't be used on this one because they're all acute angles. It can be used on this one because it's got a perfect 90-degree corner right there. And it cannot be used on this one because this one is all acute angles. So remember, you must be able to use it only when it's got a perfect corner like this right here. So looking at these, they all have perfect corners, and this symbol here in the corner looks like a little tiny square. That tells you that it is a perfect corner or a 90-degree angle right here. So when you look at it, always find the corner, the perfect 90-degree angle, and draw a straight line from it and an arrow pointing towards the opposite side. So I'll do that for that one. I'll do that for this one, and I'll do it for this one like that. Now when you're doing it, this side right here that it's pointing towards on each one of them, that's straight across from the corner, is called the hypotenuse. Okay? That is the third side and always is the longest side. It will always be the longest. The other two sides, so in this case A and C, are called legs. In this triangle, Z and Y are legs. And on this triangle, L and J are legs. Okay, so now that we know which one's the hypotenuse, or the longest side directly across from the corner, we can use that to figure out how to use a formula. Now, Mr. Pythagorean came up with a lovely formula for calculating any side that you want. And I'm just going to give it to you right here. He came up with c squared equals a squared plus b squared. Okay? Of course, squared just means you take two numbers and you multiply it together. So let's say I put a number in for c and it's 5. If I want to find out what 5 squared is, all I got to do is go 5 times 5, which is 25. So that's all squared means in that one. Okay. Now, I know the formula here now. I can switch them around if I want. If I didn't like c squared first, I could have went a squared plus b squared equals c squared. So it doesn't really matter which side you put them on. Just don't put this guy over on the other side without changing something first. And I'll show you an example of that in a moment. So if I were to take a triangle, it's got to be a right triangle. So if I were to take this triangle right here, and I'm going to put A right here, B, and C. So looking at this, here's my lovely corner of my right triangle. I'm going to draw my arrow. So this one should always be c squared. Now, what one you have as A and which one you have as B for the other two doesn't really matter, as long as you put them on the other side of C. So I can change whatever letters I wish, really. I could have had these letters be, let me see. I could have had this be J, T, and W. And then when I'm doing it, all I have to do is put this is really the c squared in my formula, so really that belongs there. The J, doesn't matter if it goes there or there, and the W will go right there. So why did they pick A, B, and C? Probably because it's the first 3 letters of the alphabet. That's why he used that in his Pythagorean's theorem. So the most important thing to do is figure out which one is always going to be c squared. So it's always going to be right across from your corner. So this will be c squared no matter what letter they make it out to be. Just fill it into the c squared part of your formula. Okay, so let's look at this one here. Remember, our formula is going to be c squared equals a squared plus b squared. Okay? So first thing I did was find my corner. I go straight across, and this is going to be my c squared, and I don't know it. So I got to leave that as c squared. Now, I do know a and b. I'm going to pick this one to be a, so I'll put 2 in for this one. So c squared equals 2 squared plus, down here, look at that, that's also 2. 2 squared. Now if I work this out, 2 squared is 4, because 2 times 2 is 4. And 2 squared is 4. So I'm going to end up with this. C squared equals 4 plus 4, which of course is 8. So if c squared equals 8, we almost got this done. The only problem we have is we need to get rid of this little squared symbol. And the only way to get rid of a squared symbol is to square root it. Okay? Give you an example of that one. If I have 8 squared and I want to get rid of, there we go. Now let's say 8 squared is 64, because 8 times 8 is 64. But if I want to get rid of this here squared, all I got to do is square root it, and that will cancel it out and leave me with 8. Of course, what I do to one side of the equal sign, I must do to the other. So what's the square root of 64? Well, I can simply go to a calculator, type in 64, and hit the square root symbol. And the answer is 8. So I'll go ahead and fill in 8 on this side. And of course, you're right, it works out. So the way to get rid of anything squared, so 2 squared, to get rid of the squared, just do that. And of course, do it to the other side as well. And that'll cancel out that. So going back to this, I want to get rid of this right here. So I'm going to go square root it. And that cancels out the square. But of course, I must do that to the 8 as well. So what's the square root of 8? Well, let's go down here. I've already got 8 there. So I'm going to square root it. So I put 8 in, and then I square root it, and it doesn't work out perfectly. It works to 2.828. I'm going to say 2.8. That's close enough for our purposes there now. So 2.8 is our answer. So this side right here, and I'll put it in a different color, this side here is 2.8 centimeters. Do we know that's reasonable? Sure. Remember what we said about the C side. It's always got to be the longest side. Always. So 2.8 is longer than 2 and is longer than 2. So we definitely know it's possible answer. Now looking at this other one over here. Okay. Now looking at this one right here. Of course we've got the same old formula. C squared equals a squared plus b squared. Find our corner. There it is. Go straight across, and now we know where C is. And again, C is not given to us. So we're just going to go C squared, because we don't know what C is. Does it matter which one we pick as A and B? No, not really. So I'm going to pick this as A, so I'll go 2 squared plus 6 squared, and there you go. Now, C squared will now equal, what's 2 squared? If I didn't know that, I just put 2 into my calculator, and then I times it by 2 again. And the answer is 4. So for this one, it's 4. And now what's 6 squared? Or in other words, 6 times 6? I know it as 36. So now my answer is going to be C squared equals 4 plus 36, which is 40. And the only way to get rid of this squared by the C is to go square root. That'll cancel him out. And of course, if I do that, I must do the square root on the other side, which is the square root of 40. So let's put in 40 and do the square root. And there's the square root symbol. 6.3, I think I'll stop at. So the answer for this one is 6.3. So let's see if it makes sense. 6.3, is it bigger than this side? Yep. Is it bigger than this side? Yes. So it's quite possible it could be the answer. Now, these ones here are all done the same. You have to do this squared plus this squared equals c squared. So again, we don't know what c is. Okay? So I can go 1 squared, which is 1, 4 squared, which is 16. So 16 and 1 is 17. So the square root of 17 will be your answer. See if you can get the answer for that one. This one and this one, same thing. We figure out where c is. C is right here. Again, we're not given c. So we're going to have to put everything else into our formula. So it's going to be 5 squared plus 3 squared equals c squared. This one here should be fairly easy. We're not given c again. And this one here should be fairly easy. We go straight across from the corner, and there's our c squared right here. And we're not given that again. So you should be able to work these out fairly easily just by punching them into the formula. C squared equals a squared plus b squared. Okay? So here's a squared, here's b squared, there's c squared. Okay, looking at this one, this is a rectangle. Now if you look at a rectangle, you know that this side is the same as this side here. So this side here is 3 centimeters too. And, of course, this side and this side is the same, so this is 8 centimeters. Now it doesn't matter which triangle you want to do. I'm going to pick this triangle going right across there. And ignore the bottom part here. I don't even want to care about that one now. I'm trying to find the distance from one corner of my rectangle to the other corner. So we know this is a right angle, so we can use our formula for Pythagorean's theorem, which is c squared equals a squared plus b squared. So where's our c squared? Ooh, we don't know it. So we're going to have to leave that as c squared. Where's our side here, a and b? Well, that's going to be 3 squared plus 8 squared. Work that out, and that's going to be 9 plus 64. Which is going to give us, let's see, 9, 10, 11, 12, 13. Oh dear, that's going to give us 73. So c squared is 73. To get rid of that squared, remember, we just simply do the square root. And then we do it to this side. So let's find the square root of 73. 73, and then hit the square root symbol. 8.5 is our answer. So this middle is 8.5 centimeters, which is possible because it's got to be the longest side anyway. Now, if you're trying to figure out what this one here is, okay, we know that halfway here is 5, so the full distance is 10. The only question we have is, do we have anything we can use here for this one for Pythagorean's theorem? Can we figure out what this little piece is right here? Well, in this one, since this is pretty tricky, I'm going to concentrate on this triangle right here. So, this blue part right here. And now I've got a nice little right triangle. I know this is 5, which is halfway, so this is 5. So in total, this whole side is 10. And C is right across from it. So I know it's going to be 4 squared plus 10 squared equals this whole distance squared, which is c squared. And of course, if I want to find out, once I figure out what this is, I just take half of it to figure out what half of this is. And that will give me my answer. Excuse me. Okay, let's look at this one right here. You might get a word problem here that has like a map, a distance from one point to the other point right here. Okay? And what you need to do then is look at the distance that it's given you. This is a perfectly right angle right here on this map. Now, if I were looking at it, on this map, it looks like it's making a perfect right angle. We know what the distance is across the bottom here. We know what the distance is across this side of the map. That's 210. The only thing we don't know is what the distance is right across this way. So let's figure out where c squared is. Go across from your corner. So this is c squared. And of course this would be a then, squared, and this down here would be b. Just plug that into your formula. C squared equals a squared plus b squared. We don't know c, that's what we're trying to figure out. We do know a squared. Well, it's 210 squared plus b squared. B is down here, so that's 340 squared. So now we're dealing with some pretty big numbers. So I'm going to have to do this with a calculator. So 210 squared is going to give me something big. 210 times 210, 44,100. So let's go back. Put that written down for this one. 44,100 plus, what's 340 squared? So let's go down here and do 340 squared. So I'm going to times it by 340 again. 115,600. So 115,600. You can see we're working with some pretty big numbers. Now we're going to have to add that up to each other. So 44,100. So I'll put that in. Oops, clear that. 44,100 plus 115,600. 115,600 gives us 159,700. So that'll give us, remember, it's still c squared, 159, and let me double check that, 700. 700. The only thing we got left to do is do the square root to get rid of the square in front of c. So I got c equals whatever the root of 159,700 is. So I already got 159,700 up there, and I'm going to do the root of it. 399, I'm going to round that off to 400, I think, because that's pretty close to being 400 miles exactly. So my answer, 400 meters, 400 meters will be this distance, which is the furthest distance. You can see another word problem like this that we have here. In this case, we're looking at an owl up in a tree, and somebody must be standing here trying to look at the owl. And he knows that the owl is 43 feet away from him, like that, but he's also standing this far away from the tree. What we're trying to figure out now is what is the total height of the tree. And if you look at the tree to the ground, it forms a nice looking right angle. So all of a sudden, we got two sides given, and we're missing one of them. So we can use Pythagorean's theorem because it is a square. Now, one thing I didn't show you before was how to do a triangle when you're not given something else other than the, there we go, a triangle when you're not given something else other than a side and the hypotenuse, or the c squared. So let's say I put a number in for c. Let's say I'm going to make 5. I think I'll make it 5. Let's say I put something in for a, and I think I'll make it 4. Now we want to figure out what is b. Well, we can always use our trusty formula again. C squared equals a squared plus b squared. Now what do I know? I know c squared this time, so I can put 5 in for c. I know a is going to be 4, but it's got to be squared. And do I know b? No, I don't know one of the legs or one of the sides now, so I got to leave that as b squared. So let's work out 5 squared. 5 times 5 is 25. 4 times 4 is 16. And of course, we don't know b squared. Now, we want this 16 to go over here with the rest of the numbers. Now, we can move him. If we move this guy here, the 16 to the other side, something happens to what's in front of it. It's no longer a plus 16, it's take away 16. So it's 25 take away 16. And remember, b squared is still there by himself. So 25 take away 16, we'll work that out real quick. 25 take away 16 equals 9. So let's look at that, and 9 equals b squared. Now remember how to get rid of the squared. To get rid of something squared, you have to do the square root. That'll cancel it out. But if you do it to one side, you got to do it to the other side. So square root of b squared is just b now. The square root of 9, if we use our calculator, there's 9. Square root is 3. So let's put 3 down there. So this side right here, our answer is 3. Does it make sense? Absolutely. We know that the longest side is always the hypotenuse, or the one across from the corner. So this is smaller than that, and this is smaller than that. So it looks like we've got the right answer. So the hardest part when you're filling in numbers and you end up with this not given, or one of the legs not given, the hardest part is always shifting the number over to this side after. Okay? So whenever you work out c squared and b squared, you always shift it over to the other side and do the opposite. So if b squared ends up being 16, when you move it to the other side, it becomes take away 16. If the b squared worked out to be 9, then when you move it over here, it becomes take away 9. Okay, so don't forget to do that when you're not given the leg rather than the hypotenuse. Okay, looking at a few multiple choice. Is the Pythagorean theorem applicable to all triangles? The answer is no, it's just applicable to right triangles. That means triangles that have a perfect corner in them somewhere. If you know the length of two sides of a right-angled triangle, we can figure the length of the third one by using Pythagorean's theorem. And of course, that is true. You have to know at least two sides. If you know two sides, you can figure out the third if it's a right triangle. So, looking at this one here, this is A, this is B, and this is C. Which of the following relations between A, B, and C are true? Okay. Oops, let me see. Move him. Oh, he won't move. That's okay. Looking at this one, is it A squared plus B squared equals C squared? Or we could say C squared plus or equals A squared plus B squared. So whatever way you put your formula, just remember, we're talking about A squared. So in other words, A squared plus B squared, and there's B squared equals C squared. So really, when you square the side of a triangle, all you're doing is making an area of the triangle, with the side of it, into a lovely square. So if I were to take this and put it together, it will add up to give me this area here. So that's all that's showing you. Looking at this side, what's the length of this side E? Of course, that is the hypotenuse because there's your corner. So this is really c squared. So just plug it into your formula. C squared equals a squared, which is 3 squared, plus 4 squared. And what do we get then? 9 plus 16 equals 25. So c squared equals 25. Just take the square root of each side, and the answer is c will be 5. 3, 4, 5 is a common Pythagorean relationship. Now if I doubled it, I could go 6, 8, and 10. So if you double the actual one, or triple, or quadruple, or 10 times each one, I could have went 30, 40, 50. Okay, that's as long as it keeps the 3, 4, 5 ratio. Same thing with this one. It's going to be c squared equals 5 squared plus 6 squared. Same thing with that one. This one's a little different. Here's our right angle, so there's c squared. So when we put c squared, it's going to be 17 squared equals a squared is there. So I'll call it e squared because that's the letter they picked. Plus 15 squared. So all you got to do is take this after you go 15 times 15 and bring it over here and take it away. And then you square root each side. Here's another one where you know you're going to have to shift it because there is c squared right here. So there's c. So when you plug it into the formula, it's going to be c squared equals a squared plus b squared. C squared is going to be 15 squared equals 9 squared plus whatever e is, e squared. So I multiply that by itself. So 15 times 15, 225. So I get 225 on this side equals 9 squared is 81 plus e squared. Now to get that 81 moved, shift to this side. You're going to have 225 now. Since we're shifting them, it becomes take away 81 equals e squared. So 225 take away 81 leaves us with 144. So we got 144 equals e squared. To get rid of this squared, we do the root. And that cancels out the squared. But of course, what you do to one side, you must do to the other. So we've got e left all by himself. What's the square root of 144? Well, let's take 144 and hit the square root button. And the answer is 12. So our measurement for e right here is 12 centimeters, just like that. Okay. So here's another one. Use your formula. 6 squared plus 6 squared equals e squared. Okay. So all these are pretty much the same. You just got to remember to use your formula and plug it in and move stuff around if you have to.